In the previous section, we improved speed and determinism using various techniques. By the end of this module, you will be able to describe considerations when selecting an inter-process communication method. In Lesson 5, we're going to talk about inter-process communication. So what this means is, on your RT target, if you have an RTVI and you have multiple loops on there, well, sometimes you need to share data between those loops. Inter-process communication is going to describe the method that you would use to communicate those values between multiple loops on your RT target. So we'll talk about sharing that data locally on your RT target. We'll talk about how do you share data between a deterministic and non-deterministic loop. And then we'll also talk about how to share data between multiple non-deterministic. So here we see a familiar picture. This is a graphic we've seen previously in the course that kind of describes a real-time application along with the host application. So in this chapter, we're talking about inter-process communication. The communication that we're talking about is going to lie within the RT target. So notice we have non-deterministic loops on our target. We also have deterministic loops. And there's different ways to communicate between these different loops. So right now, let's take a look at non-deterministic loops and a deterministic loop. So if you're going to use some sort of inter-process communication between a deterministic loop and a non-deterministic loop, then we have to make sure whatever method we use is going to be something that does not negatively affect the determinism of the deterministic loop. We still want to make sure that the deterministic loop is running on time every time. That's why we kind of separate that out in a section in this lesson. And communicating between two non-deterministic loops, we don't have to worry too much about keeping the determinism, so we'll talk about those separately. Okay, so what are things that you need to ask yourself before choosing which inter-process communication method to use? So the first thing you want to ask is, okay, well, are you going to be communicating between a deterministic loop and a non-deterministic loop? So that's going to be yes or no. And also, do you need to transfer latest value, or do you need to transfer every value? So for example, do you need to just transfer the most current set point, or do you need to transfer every acquired value and not lose anyone? So at the bottom of this slide, you see a chart with kind of the answers to those two questions. So you see the column of deterministic loop and non-deterministic loop, and you also see a column for non-deterministic loop and non-deterministic loop. And then for each of those, we talk about, okay, well, do you need the latest value only, or do you need every value? And the cells within that table kind of tell you the different methods that you can use for each situation. And we'll be talking about these during this lesson. As you can see with the asterisks, some of these we don't go into detail for this particular course, but some of them are going to be covered more in the LabVIEW Real-Time 2 course, and also Q's are covered in the LabVIEW Core 2 course. So in the first part of this lesson, we're going to talk about the deterministic loop and non-deterministic loop piece. So we're going to talk about the left side of this diagram. And then in the second half of this lesson, we'll talk about the non-deterministic loop to non-deterministic loop for the right side of this diagram. Now you can describe considerations when selecting an inter-process communication method. Next, we will configure a single process shared variable with RT FIFO enabled to share data between a deterministic loop and non-deterministic loops. In the previous section, we described considerations when selecting an inter-process communication method. By the end of this module, you will be able to configure a single process shared variable with RT FIFO enabled to share data between deterministic and non-deterministic loops. So in this section, as you can see in the graphic above, the piece that we're going to talk about is how to do inter-process communication between a deterministic loop and a non-deterministic loop. So we'll talk about two different use cases here. So if you look at the chart at the bottom, notice that there's a latest value use case and also a every value use case. So let's talk about the latest value use case first. So let's say we have a deterministic loop and we need to communicate the latest value to the non-deterministic loop. So that's kind of what we see under the description. We only need to share the latest value. So some examples of this is maybe we want to check if another loop has stopped. So we just kind of see the status of some other loop through maybe a Boolean. Or maybe we just want to monitor the current I/O values. So maybe we're acquiring some I/O value, and maybe we are just sharing the latest value of that I/O value with another non-deterministic loop. How about the every value use case? So in this case, maybe we need to share every value written, and to do this, we'd have to use a multi-element buffer. in this case, we don't want to lose any values. So one example of this is maybe we want to acquire some data in our deterministic loop, and we want to send all of that data to some other non-deterministic loop to do the file logging. So in this case, the file logging itself doesn't need to be deterministic, so that's being handled in a non-deterministic loop. However, we need to get all the acquired values from our deterministic loop all the way to the non-deterministic loop. So in this case, it's not the latest value that we're concerned with. We want to get every single value that we acquired in that loop. Or possibly we want to send all that buffer data to a non-critical data processing and analysis loop that doesn't have to run deterministically. So as you can see, this goes back to the chart or table that we saw at the beginning of this lesson, and this is the piece that we're going to look at, okay, the one that's highlighted in red. So what we'll be talking about is how to use single process shared variables with the RT-FIFO enabled to accomplish this. To accomplish this with the latest value use case, we're going to use a single element. And for the every value use case, we're going to use a multi-element FIFO. Okay, so first of all, let's talk about what are single process shared variables in the first place. So these are going to be very similar to local or global variables on the block diagram, with a couple of additions. So shared variables will have error terminals. So if you take a look at the block diagram at the bottom of the page, you see that we have a shared variable that's named variable1. And notice that it has error terminals. But otherwise, if you take a look at it, you're just wiring in a value in one case, and if we look at the second part of that block diagram, the same variable, we can read data from it as well. So notice that that's very similar to local and global variables. So shared variables are more like global variables in the sense that if you define a shared variable, you can use it in not only multiple loops, but also multiple VIs. The other thing that they have in addition is timestamps. So you can also configure a shared variable to return a timestamp. That way you can see when the returned data was actually written to that shared variable. So the way that you would do this is in the configuration window, which we'll see later. We can enable the timestamp, and we can also right-click our shared variable afterwards and configure it to show the timestamp terminal. Okay, so now let's take a look at the Project Explorer window. So in the Project Explorer window, you see that the shared variable resides in your Project Explorer. And notice that you see variable 1 there. That's our shared variable, and then it resides in a project library. So you see that it's in a .lblib file. In a few slides, we'll talk about how to actually create the shared variable in the Project Explorer. So these shared variables that we just described can be used non-deterministically and also deterministically. So if we take a look at this table, we're talking about a single process shared variable, and there's an option on there called the RT-FIFO, and you can either enable it or disable it. So if you have that single process shared variable with the RT-FIFO disabled, then you can use that shared variable to transfer data between non-deterministic loops or VIs. However, if you enable the RT-FIFO option, then you'll be able to use that shared variable to transfer data from the deterministic loop to other loops without affecting the determinism of the deterministic loop. So if you're placing this shared variable inside a deterministic loop, you definitely want to enable the RT-FIFO option. Okay, so let's talk about how to create a single process shared variable with the RT-FIFO enabled. So the first thing you would do is you would right-click the target or library and select New Variable. Next you would set the name of the variable, as you can see at the bottom screenshot there. In this case we've named the variable data. Then you would set the variable type to single process. Then you would select the data type. So in this case we've chosen the double precision number as our data type. So in this case, since we're creating a single process shared variable with the RT-FIFO enabled, because we want to make sure we can use this inside a deterministic loop, I want to make the note, RT-FIFOs do not support data types of variable size, such as strings. So if you think about it, strings are a variable size. For example, if you have a string, you want to be sure until you actually write it whether it's 10 characters or 20 characters or 100 characters. That's why strings are considered a data type with variable size. On the other hand, if you have a double precision number, you know every single time it's 64 bits. So it's a fixed size. Or if you had a unsigned 8-bit integer, you know every single time that's going to be 8 bits. The next thing you would do is on the left-hand side, you would select the RT FIFO category, and then at that point, on the right-hand side, you can enable the RT FIFO. So just make sure that that option is enabled. And then after that, you would configure the FIFO type. So you can set the FIFO type to either multi-element if you want to communicate every value, or you can change it to single element if you want to only communicate the latest values. Notice that on that screenshot towards the left, if the RT FIFO is enabled, you will see some vertical purple lines on the shared variable icon to indicate that the RT FIFO is enabled. So notice here that if you were only wanting to transfer the latest value, the RT FIFO is enabled and the FIFO type is set to single element. On the other hand, if you need to communicate every value, or in other words, you need to send buffered values, you want to make sure that the FIFO type is set to multi-element. And notice after you set the FIFO type to multi-element, you can also set the number of elements in that FIFO. In this case, we've set that FIFO to a size of 100 elements. So just in case you've never worked with FIFOs or queues before, the word FIFO stands for first in, first out. So if I was to place in a number 100, 200, 300, and then 400 when I'm writing to the FIFO, when I read from the FIFO somewhere else, the first thing that I'm going to read is going to be 100, and then 200, then 300, then 400. So in other words, the order that you place elements into your FIFO will be the same order that it's read out of the FIFO. Okay, so let's quickly take a look at how we would configure and create a single process shared variable with RT FIFO enabled in LabVIEW. Okay, so presumably I need to create this variable to communicate between a deterministic loop and non-deterministic loop that's on my RT target. So therefore, I would need to create this variable on my RT target. So notice my RT target is right here. I'm going to right-click my RT target, go to New, and then Variable. Okay. So once I've done that, I get this window. Let's say I just need to get some sort of data. So I'm just going to call this my data. And here I can say I want this to be a single process. We're not going to talk about network communication quite yet. So for now, I just need to have a variable to communicate between loops that are on my RT target, and it's just going to stay within my RT target. So I'm choosing a single process here, like this. And then I get to choose my data type as well. So I could choose some other data types, but I'm going to keep it with a double precision number. Okay. Next thing I'm going to do is, before I get to that, notice that there's an enable timestamping option here. If you want to get the timestamp of your data, you have to enable this, but I'm going to keep it disabled for now. The next thing I want to do is, because I'm going to use this in my deterministic loop, I want to go to RT FIFO over here, and I want to enable it. Okay. If I'm only communicating latest values, then I can keep the FIFO type at single element. However, if I want to transfer every value or buffered values, I need to choose multi-element. And then at this point, I can choose how many elements I want in this FIFO. So maybe for now, I'm just going to put 50. Okay. Now I'm going to click OK. And now I have my my variable right here. So notice if I create a shared variable, it automatically creates a library for me, which I'll have to save eventually. So right now I'm just going to save it. I'm going to click Save. And then I'm going to call this my variables. Okay. I'm going to click OK. So notice I have my variables, and I have another shared variable here. Notice that it has these vertical purple lines to indicate that there's an RT FIFO. If I wanted to add another variable to this, or shared variable to this, I could right-click my library, click New, and then Variable. And this time, I'm just going to create a quick one. I'm going to call this Stop, so I can know if one of my loops stopped. Again, I'm going to choose Single Process. I'm going to choose Boolean. And then I'm going to go over to the RT FIFO category, and I'm going to enable my RT FIFO. And in this case, I only care about the latest value of that stop, right? I just want to know if the latest value is true or if it's false. So I'm going to keep it on single element. Click OK. And notice now I have these variables. Okay? So now that I've created the variables, I can actually put this into a RTVI just by dragging them onto the block diagram. In the previous section, we configured a single process shared variable with RT FIFO enabled to share data between deterministic and non-deterministic loops. By the end of this module, you will be able to handle initialization, overflow, underflow, and multiple readers and writers properly when using single process shared variables with RT-FIFO enabled. Okay, so let's talk about initialization first. So the RT-FIFO that's in your shared variable is created the first time a variable is read or written. So if we keep this in mind, that means that first time that we're writing or reading that variable with the RT-FIFO, it's going to take a little bit of more time. Okay, so there's going to be some bit of delay because it needs to create that FIFO. So one way we can deal with this is you can write a meaningful value to the variable before the main loop to create and initialize the FIFO. And that way the delay is done outside of your main while loop. So if you take a look at the example at the bottom, notice that we have initialized our variable here with 0. Okay, so when the code gets to that point where it's writing to that variable for the first time and writing a 0 to it, it may take a little bit longer just because it's creating that FIFO. But once that's been done, then when we're inside the while loop, there's not going to be any more delays when you're writing or reading to that variable with the RT-FIFO. If you don't do this, then you just want to make sure that you allow for extra jitter in the first iteration of a loop that uses that variable. However, usually it's good practice to initialize your variable before the main loop anyways. Okay, so let's talk about if you're using a single process shared variable with RT-FIFO and it's a multi-element FIFO. So in this case, we're using it to communicate every value or buffered values from a deterministic loop to a non-deterministic loop. So what happens if we have this variable and we set the RT-FIFO to be a size of 10 elements? What happens when we start writing to this FIFO and let's say we're not reading out fast enough? So let's say we fill it up to 10 elements inside the RT-FIFO and then we try to write another element to that FIFO that's already full. Well, what will happen is you'll actually get an error code that's outputted for -2221. So that way you can check if an overflow has occurred. Now, if an overflow occurs, what will happen is it'll overwrite the oldest unread data in that RT-FIFO with new data. And we'll take a look at this in a demo real quick. So notice if we look at the LabVIEW code for this, we have our variable with the RT-FIFO that you see inside the while loop. We're writing data to it, and what we can do to check for overflow is you just take the error wire coming out of that variable and then look at the code that's associated with it. If you see a code that's -2221, then you know overflow has occurred, and then you can take action based on that. So if overflow is occurring, and that means we're overwriting our oldest unread data, which means we're actually losing data at this point. Okay, there's been data that has been lost and overwritten that we'll never get to read. So in this case, the way we're dealing with it is we're just outputting a true value to an overflow occurred indicator. Now in your actual application, you could do something more complicated than that. Maybe an overflow means that you need to stop your loop and maybe take some recovery action, for example. Okay, so let's talk about underflow now. So underflow occurs when you're trying to read from a multi-element FIFO, but there's nothing in that FIFO. So if you do that, then you'll get an error code of -2220, which indicates an underflow. Okay, so if we look at this block diagram real quick, if we're trying to read from variable 1, which has a RT-FIFO of 10 elements, and we're trying to read from it, and there's nothing in that RT-FIFO, so there's 0 elements in that RT-FIFO, well, we're going to get an underflow. So if you check the code of the error wire coming out of there, you'll get an error code of -2220. Okay, so let's jump into LabVIEW and take a look at this. Okay, so let's take a look at overflow and underflow. So I've created a VI here that will demonstrate overflow and underflow conditions. And if we take a look at the block diagram, notice what we have is we've got a shared variable here, a single process shared variable with RT-FIFO enabled. And this is a multi-element FIFO. So this is result data. It corresponds to this one right here. So let me just show you real quick. If you get into the properties and you go to RT-FIFO, notice that the RT-FIFO is enabled and it's a multi-element FIFO, and it has 10 elements in there. Okay? So now let's go back into here and let's look at the code. So in the writing loop, every time I click write over here, it's going to go ahead and execute this code. So essentially what we're going to do is when I write it, it's going to write a 1 to my result data, and then 2, and 3, and 4, 5, and it's just going to keep incrementing. Okay, and we'll see what value was written right over here. Okay, and we're also going to monitor the error wire here. Okay, so we can see when the error code is associated with the overflow comes out. Okay, and in the same way on the read side, we're just going to read. Every time I click the read button, it's going to read data from that RT FIFO. Okay? And we're going to monitor the error wire as well for the underflow error. Okay? So let's go ahead and run this. So I'm going to save it. Everything. It's going to deploy. Okay, so now we're ready to rock. So let's do write. So notice I've written the value 1 to my single process shared variable with RT FIFO. And I'm going to keep writing. So I'm going to write 5 values right now. Okay, and then on my read side, I'm going to go ahead and read, and notice that they come out in the exact same order.